KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
And my name is Reada McConnaughy, and I'm a math teacher with Northern United Humboldt Charter School, and you're watching Homework Hotline. Welcome.
I'm so happy that you guys have tuned in.
We are going to do a show on our show, we're going to talk about something that we did last episode, which was burn some candles, and we still have the candles in front of us. Last episode was on combustion, and our science teacher, Ken, talked about combustion. Pam, you're a science teacher. Yes. Any quick review of what combustion is?
Well, combustion is basically taking something that contains carbon and adding oxygen to it. And then as a result of that, you get, well, usually it's a carbohydrate. So, I mean, something that has carbon and hydrogen. Okay. So the result on the other side of the equation is that you get carbon dioxide, and you also get, heat, of course, when you do that, and you also get water as one of the products.
Cool. So we took the candles from the last episode. They are still up here in the front. And we, on our whiteboard here, we put all the data in. Let me see if I can scroll down just a little bit to get to the data. Here we go. And we did time. And then we have 6 different candles that we had burning. We're going to add one more candle. We're going to burn another birthday candle. Okay? So we're going to burn another birthday candle, and then we're going to measure it over time. And why I wanted to do the birthday candle again is because last time, if we come back and look at our birthday candle from the previous episode, it burned all the way to the ground.
Oh no.
Oh no.
Oh dear.
So birthday candles, I guess, do not last very long.
The time to sing happy birthday or whatever.
Yes.
And blow them out.
Okay, so Pam, if you don't mind, I'm going to have you first measure the candle.
Sure, will do. And you want it in centimeters?
Yes, please.
Okay, great. So I'm going to look myself because I can't. Okay. Or would you like me to measure to the very wick? The wick? Do you want the wick?
I think the wick, yes.
Okay, awesome. So I have 6.1 centimeters.
Okay, and then could you turn it around for the camera?
Of course.
And I will try to type that in our chart here.
Just above the 6 centimeter.
So birthday, our second birthday. Oops. Let me go here, copy that, paste it. Birthday number 2. Okay. And then you said it was 6.1?
Yes.
Centimeters. And then I was thinking, you know, it's not really 0.1, it's 6 1/10.
Right.
I know science, we may say 6.1, and no problem, that's great. You can keep doing that, but since we're in math, we should be mathy and say 6 1/10.
We should, and I really appreciate that because I work with Amy Taylor normally, and she always tells me the same thing. But I can't remember it.
Us math teachers, we stick together.
That's good.
Okay, so that's at 0 minutes. It's 6 1/10 centimeters tall.
Yes.
And then we're gonna light it.
Okay.
And have a timer.
Oh dear, I don't know. Let's see. I think I'm gonna need your assistance with this because you just press this, or is
I had the same problem.
Is it on? Oh, look, that's positive. That must mean on. Oh no, not. Okay, I need your help. Sorry.
Okay, no problem.
Oh, look how simple that was.
Yay,
Reada. I was holding it the wrong way or whatever.
Okay, so we're going to try to measure the height of the candle after 3 minutes. So I'm going to set a timer for 3 minutes so that we know to do that.
All right.
Oops.
Great. Something to look forward to.
Yes. All right.
Excellent.
There we go. So that timer will go off. So in the meantime, we're going to look at how the candle heights changed over time. And that is something called rate of change. Now we can see that on the graph. If we can go over to the graph, and it would be, let's see, could you try to scroll that down?
Sure.
Over on the side.
Scroll it down. Yes, yes, of course.
Okay. Or we can open up.
Okay. You
Okay.
practice with this.
So the first graph you see on the bottom, that was just the simple measurements over time.
Did I just mess up? No.
Oh, you're good.
Okay, good.
And then I put those round circles as our measurements. I put them as stars. And then what happened is I was able to draw a trend line. You may think of it as a line of best fit, but when it's with data, it's a trend line. And our trend lines show that the candles may be burned at different rates. Okay? Which one do you think burned the quickest?
Burned the quickest, the one that changed, had the greatest slope, maybe?
Yeah.
So would it be the bottom one? The one that, nobody can see me doing this, but the one that's on the
can
bottom
now.
that's, okay, excellent. There, right here, this light blue line here, would that be the fastest?
Yep, and that was our birthday candle, and it burned
Oh,
so quickly.
that
And then we
makes
talked
sense.
about how the wax, different types of wax would, the fuel, the wax would burn quicker or less quickly. Which one burned the least amount? Can
The
you
least
tell?
amount would be the flattest, and this guy right here, this, well, yeah, I think this pink line.
Mm-hmm.
Oh, and if I look up here, I can check it out, because there's a legend, pink. Oh, I don't know that we went with pink. Is that,
Yeah, the first chart had different colors. It picked a blue color
this
for
red?
the red candle. So the first one is, this one is the red candle, this is the off-white candle. If we
Okay.
look at our candles,
yes.
the height show us the tallest
Mm-hmm.
was the red, and the one that burned the smallest rate was that second off-white one.
Mm-hmm.
And we talked about how that diameter of that candle is wider,
Oh.
and then it made more of a well, how
Yes.
the wax went inside.
So the melted wax, yes.
Yep.
Neat.
Okay, so rate of change, you can create these charts on your own, and it would take some math, some subtracting in this case, okay? And then you can connect it on a graph to how a line might slope. And we had these decreasing rates of change. How as time went up, the height of the candle went down, okay? And that gave us some decreasing lines.
Oh,
it's our
3
timer.
minutes. Yay. Okay.
Okay, so
So
let's measure.
Try to avoid burning the ruler. And now we have 4.5, or 4 and 5/10. 4 and 5/10 centimeters.
Perfect. All right, thank you.
You're welcome.
And then our next timer is at 7.5
Okay.
minutes. So I'm gonna put on here another 3 minutes, and
Okay,
then we'll
we'll measure it again.
That'll be pretty close.
Very good.
Okay, so our candles, the height went down as time went up,
Yes.
okay? But we're gonna do a rate of change where as time goes up, our capacity will also go up. So it'll be an increasing rate of change. And that we're gonna do with water.
Okay.
So over here, Pam has been my helper. And we did a few pumps of water already. And we kept track of it. It's kind of small, sorry about that.
Can I make this bigger?
I
I
think
probably
so.
can.
Yep, I could try to do that
Okay,
too.
sweet.
We'll see if I can make it bigger. So we did up to 3 pumps,
There you go.
a little bit better.
Definitely.
And we had 1,682 grams, okay, after 3 pumps of water. So we're going to turn on our scale. We
Okay.
found out that we need to do that,
Okay. Scale is on.
okay? And then put our bowl of water back on.
Then it says it's ounces, and I want to change that, right?
Yep, we want it to be in grams.
Okay. It's pounds. No, I'm grams. Okay, I got
Yay.
grams. Here it is, 1,681.
Okay, so 1,000, oh, say it again for me.
1,681.
1,681 is what we had, okay? And now we're gonna add a pump.
Okay, let's do it.
So this will be our 4th pump of water. Nice work.
Thank you.
Okay,
All right, so now we have 1,787 grams.
1,787 grams. Okay, now we are going to do a quick chart with that data. And what it's going to measure is the pump went up by 1 each time, and then it'll show us graphically how much the water went up with the 1 pump. All right, let's see what our chart looks like. Well, let me see if I can make it be a little bit different of a chart. There, that one's just a little bit better. So, Pam.
Oh yeah, that's nice.
Yeah, so if the blue represents the water,
yes,
at pump 0, so way over here,
yes,
at pump 0, right? Why is it at 1,500 grams?
1,500 grams because we're also weighing this contraption, the bowl, yes.
All right, so that's the bowl. So really the water is just this triangle part up here.
Yes.
And but it's increasing.
Oh, it's time to measure the candle.
All right.
Okay, here we go. Looks like we have, I'm going with 3.2 centimeters.
Okay, 3 2/10 centimeters. Thank you very much.
You're welcome.
Next is at 11 minutes, so that is 10 and a half, probably another 3 minutes.
Okay.
Then we'll measure it.
All right.
All right, so water increases, the rate of change is going up. Now, if you're wondering how do you calculate this rate of change, let me go back to our chart. Let's see if I can move this out of the way. Over this way. Okay, so I could do the math on here and find out how much it is changing. And the cool thing about using a spreadsheet like I'm using is you can do the math on there. You just start with an equal sign. So I'm going to take the pump 2 and I'm going to subtract the first pump. And we have a difference of 99 grams.
Ooh.
So your first pump, it was 99 grams that it went up.
Yes.
Okay.
Good.
So if we were consistent, the second pump should be 99 grams.
Yes.
All right. So let me do the same math. I'm going to pull it down. Subtract. 87 grams.
Well, you know, it's possible because when I press this, I can press it and I think I can make more or less come out of this in terms of pump. So it's not like perfect pumper.
Gotcha.
Yeah.
And that doesn't happen in science very often, right? That you get perfect.
All the time. That's what science is questioning why it is the way it is.
All right. And then let's go up one here. Hold on. Okay. So I want to go and do our fourth pump. Let's see how much. 105 grams. Wow.
Well, I really pumped it that time. I'm getting stronger, that's
Here
why.
we pump you up.
Yeah, that's right.
At Homework Hotline. Okay, so in any ways, we saw the rate of change, how it went up instead of down like the candle heights. We're going to go down.
Yes.
Okay. And when you learn rate of change, I think it's a 6th grade standard that they start learning about rate of change. You start learning about slope soon after that.
That makes sense.
And slope, you'll learn it's the rise over the run. So the vertical change over the horizontal change. Cool. Okay, so we're going to go and introduce this sign. So hopefully we can bring this sign up. This sign is a picture, or it's a picture of a sign from Highway 36. And if you've ever been to Highway 36, head out to Ruth Lake, you'll see this sign, and it's a truck going downhill, and the percent grade says 10% grade. We'll talk about that in a little bit. You got our measurement?
2 centimeters, yes.
Okay, we're measuring our birthday candle, 2 centimeters. All right, thank you.
You're welcome.
Let me set the timer, another 3 minutes. Okay, So if you've driven along on the highway and you've seen a sign like this where it has a percent, it might have 6%, it might have 7%, 3%, 4%, but 10% is pretty steep.
Sure is.
It's the steepest I've ever seen. I thought I had seen 13% before, but I might have been
You wouldn't
dreaming.
be showing a truck going on that, right, or something.
Yeah, I really think I was dreaming.
Man, yeah, that's very steep.
Another time you might see this slope or this type of grade percent is on this kind of sign. Maybe we can zoom into this one. This is Patrick's Point, the Overlook Trail, and it has hiking. And down here, it has that the typical is 3%, and the maximum you might go up is 7%.
Yeah.
Okay, so different trails you're going to see where slope, they would talk about slope.
And that'd be helpful to know as a runner, so you know that you're going, because when you go up a steeper slope, then you're using more energy, and so it might require more energy than you want to do at any one particular time. So you may want to stick with the 3% rather than the 7%.
And going back to this sign with the traffic on a road, a trucker, someone driving something that's heavy, they need to know. Let's see, I don't know if we can zoom in, but what's that say on the bottom?
I think it says trucks use lower gear.
Lower gear.
Because if they're going too fast, the truck is really heavy. I mean, usually these trucks are pretty heavy if they're full anyway, and that has to do with a variable called inertia. And inertia is the heavier something is, the greater the mass is, the more likely it is to continue in whatever pathway it's going. So if it's just driving on a straight line and then you put the brakes on, it takes a lot more effort to put the brakes on. In this case, you might lose control of your vehicle.
Yeah, or you're riding a bicycle, right? You're riding a bicycle and you're going down a hill, right? Just looking at this, I'm not going to want to drive this bicycle down this steep a hill, right? I'd want to, maybe even this is too steep. You got to be careful.
But
right?
you never know. If you had on the other side another ramp like that, because some of those crazy bike jumpers and the people who do skateboard stuff, they have a ramp on the other side, and so they can do all these kinds of crazy like spins and turns and stuff. That's kind of neat.
I wonder at a skateboard park, what their percent grades are.
Oh yeah, oh my goodness. Some of them, it seems kind of crazy. How could they even stay on while they're going almost straight down? Yeah, in competitions.
Right.
Yeah.
So maybe don't try this at home unless you're trained on how to do it.
Right.
Okay, so, it is our timer.
Oh my Lord,
goodness,
it's almost
our birthday
done.
candle.
Okay, I have 0.7.
So
0.7 centimeter, or 7/10 of a centimeter.
7/10 of a
7/10 of a
centimeter.
centimeter.
It is going to be out before it's even 3 minutes.
I'm afraid so.
Okay, so I'll put the 3 minutes on. Very cool.
Okay, nice.
Okay.
Getting smaller and smaller.
Yes. Let's see. So what is the math? Like, how do they figure out this 10%? And since we're using the 10%, that is going to be, we're going to be able to see the math easier. So
Okay,
I'm going to come over to the board.
Okay.
And I'm going to hopefully turn it over to the marker board.
Awesome. Do you want me to say anything, or do you want to discover this?
You're
going to discover it.
Yeah, I'll
Cool.
draw the triangle.
Excellent.
Okay, so we talked about slope as being rise over run. So slope is the rise or the vertical change. Sorry, that's supposed to be an S. Over the run. Okay, and if you need arrows, it is the up or down. It could be down over the right or to the left. Okay, so I'm going to draw a road here, and I'm going to pretend that this is my 10% grade road. Now that doesn't look very steep, does it? So, but if you are driving, I'll do oops, go away. Okay, if I'm driving my bicycle, this is the math teacher trying to draw a bicycle. Okay, so you pretend that's a bicycle. Okay, and I'm going down this hill, and it has a 10% grade, that means that for every 100, and I'm going to use feet in this case, for every 100 feet that it goes to the right or to the left, it goes up 10 feet. Okay? So for every 100 feet it goes of run, it goes up 10 feet. And if I would come up here and I would divide those, my 10, which is my rise, over 100, I get the decimal point 0.1 or 1/10. And then do you remember how to change decimals to percents?
Decimals to percents. It has to do with, so that's 10% because it's one place over from the decimal point. I don't know. I'm sorry, help me out. Help me out, math teacher.
I would love to.
Thank you.
Okay, so since it's 1/10, 0.1, let me try to get a better decimal point here. While I'm doing this, do you want to
oh my
check
goodness,
our candle? And I think it's at 0.
Holy mackerel, it's way down there.
Yeah, I don't think there's much left of our birthday candle. It's probably burning the
Yeah, I think
cutting
it
now.
is. I do think it is burning.
Okay, so it's at 0.
We'll call it 0, yeah.
You want to blow it out? Then
Sure,
we
we'll
don't
do.
have to...
Right, fix the table once it burns.
Happy birthday!
Hey, yay!
Okay, so back to the 1/10 or the 0.1. I'm going to write it on this side. So 0.1 or 1/10. If you want to change it to a percent, we multiply it by 100. Easiest thing is just move the decimal point over 2 places. That would give us 10%. So this sign that has a 10% grade was telling those who are writing down it that for every 100 feet you're going to go forward, the road's going to go down 10 feet. Okay?
Yes.
Doesn't seem like a lot, but when you're driving a vehicle and these wheels, right, the inertia is much.
Well, it's the friction, I think, in terms of, like, it depends on the wheels you have. If you have those big fatty tires that are good for, like, mud and sand, it would give you more friction. But the less that you have, if you're driving a 10-speed or whatever they call it, a road bike, and it's really skinny tire that doesn't have any tread at all, the tread is what slows you down because the tread gives you more contact with the surface.
Okay.
So if you don't have much contact, man, you are really speeding.
Yeah.
Yeah, without brakes. You gotta have brakes.
Gotcha. Okay, so at this point, I want to look at just some other examples where you might want to have 0 slope, right?
Yes.
0 rate of change, or that it, as time goes on or as the rise goes on, you don't want to go up or down.
Okay.
For example, in your house, right, you want to have a flat foundation,
I
right?
can think of an example like a washing machine. So we have a washing machine that we didn't level, and so it was on a, a sort of a
off balance.
off balance, and so it messed it up, and so we had a guy come in and he fixed it. It was like, yay! So it made it balance. So it was not, like you said, on a slope. Yeah.
Gotcha.
Flat, important.
So horizontal lines have 0 slope, and if you have a bathtub or the wash machine or anything else that you need to have a level surface,
Yes.
where it has 0 slope, that bathtub. But let's say you want to, this is going to be funny, you want to keep the dinosaurs out. Have you seen the Jurassic Park?
Yes,
Okay.
of course, of course.
So keep the dinosaurs out, and you want a slope that is just right upright, right?
Yes.
So keeping those dinosaurs, this slope is a little different because it doesn't have any run. It still has rise. Then we would take the rise divided by 0 run.
Mm-hmm.
And can you ever divide by 0?
No, because
No.
It
And
doesn't
if you've ever asked Siri or one of those, how do you divide by 0? It's kind of a funny thing. But it says Cookie Monster has 0 cookies and 0 friends, which is no fun. So 0 slope, horizontal, or the vertical lines, brick wall. It's called undefined slope.
Cool.
All right. So if we had a green screen, we could pretend we were walking up the slope, you know, and the different exertion we would have on there. Okay.
Definitely.
We looked at a lot of different things. Do you have any questions?
No, this is very cool and so applicable. I mean, I can think of this applying. I was in track in high school, and I rode bike when I was a kid, and just all the times that it made a difference. Like, you have to put the bike into lower gear so that you're spinning faster, rather than, so that your pedals spin faster, and you don't have to exert as much effort into getting up the hill. So when your pedals, if you go into a higher gear, your pedals are going around slower, and you usually do that on a flat surface. But if you're in a lower gear, that helps you to get up the hill, because I'm not exerting as much effort as I go round and round with my pedals.
Gotcha.
Yeah. So anyway, that's why gears are so important in either in anything vehicular.
So bicycles have gears, vehicles have gears. I'm sure machinery, different types of machinery, they have to change the gears according to what the slope is. Okay, so as you go driving around in the vehicles, check out the signs on the road. See if you see anything that might be greater than 10% grade, because this is very steep for Humboldt County.
Yes.
And I bet we have some roads, some off-roads that are even more than the 10%.
Probably so, yeah. We have a little road next to our house that takes you down into this green belt, which is a place where there's trees and a trail, and it's very steep, and I don't know that it has any warning or anything, but you're like, whoa, that's, yeah.
Yeah, and then as you go to different trails too, you're gonna see these percents of grades, and so it's 3% on this trail is a typical one, and then it might go up, okay?
Yeah, nice. And it's good to know in case you want to bring extra water because you're going to be exerting yourself more or anything like that. Yay.
So
this
it's
is
fun to get out, look at slope around you.
Yes.
You're going to see slope when you walk into a door. Sometimes there's a ramp.
Oh, yeah.
And those ramps are going to have different, specifications. It can't be greater than a certain ramp, otherwise the wheelchair would go down.
Absolutely, and those wheelchairs now, they have things that have like bumps on them, and to keep the wheelchair from slowing it down rather than going straight down the thing.
Awesome.
So anyway,
so look around your world. You're going to see slope and different rates of change all around you.
Yes. Thanks so much for tuning in,
Thank you,
everybody.
guys.
We're so happy that you did.
Yeah.
We'll see you again on Tuesday.
You're going to have to fix your wash machine, aren't you?
Yeah. No, fortunately it did get fixed, so we're happy for that.
Good,
so,
good.
yay.
Bye.
See ya.